بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله جميعا. بسم الله والصلاة والسلام على رسول الله. Thank you everyone for being here. I'm hearing myself. بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله جميعا. بسم الله والصلاة والسلام على رسول الله. Thank you everyone. سكر Okay, there was just another microphone in the room. Sorry for this. Okay, I'm very glad and delighted to start the conference, and it's a big honor to give the token to Dr. Ahmed Yamani, the president of I'm hearing my voice for some reason. I'm hearing my voice for some reason. Okay, so please, Dr. Ahmed, you may start giving the speech.
Assalamu alaikum wa rahmatullahi wa barakatuh. Hello, everyone. Greetings to you all from Riyadh, Saudi Arabia, wherever you are. Today, we have gathered online to reflect on our determination to continue our commitments to contribute to the development and advancement of science, research, and innovation. At this exceptional and challenging time, and for the sake of each and everyone's health, we are communicating with one another virtually. It is a great pleasure for all of us at PSU, and we are indeed pleased and delighted to have our distinguished scholars and guests joining us at this timely conference. We welcome you all, and we thank you for participating in an important conference, not only to the kingdom, but also for the whole region. The first international conference on smart systems and emerging technology, SMARTTECH 2020. Before making a few more remarks, we would naturally like to thank the organizers, Robotics and the Internet of Things Lab at the College of Computer and Information Sciences, jointly with PSU Research and Initiative Centers. Once again, that talent team has succeeded in bringing together on a virtual platform local, regional, and international academics, researchers, practitioners to share and discuss important issues and exchange of ideas in regard to recent development in the cutting-edge technologies that are vital for modern societies. Artificial intelligence is undoubtedly the new electricity in the 21st century and has been evolving exponentially in the last decade and enabling a vast array of outstanding applications that were not possible just a few years ago. The SMARTTECH 2020 conference includes 5 sessions with more than 20 quality papers around AI that will be published by our technical sponsor, IEEE Explore database. The conference also covers a wide range of topics around cybersecurity, which is of great interest, not only in the kingdom, but also around the globe, considering the increasing number of threats that compromise security and safety worldwide. The conference presents rich and diverse programs that certainly will contribute to the advancement of research and development. A salute is warranted here to the Robotics and Internet of Things Lab. The lab has been heavily involved in conducting data science and artificial intelligence research. It is today developing cutting-edge AI solutions in several fields, including healthcare, public transportation, national security and safety, Hajj and Umrah applications, aerial and ground unmanned systems, smart agriculture, social networks, sentiment analysis, to name a few. We need also to thank those scholars who will be speaking and making presentations and participation in forums. For those from PSU and local institutions, let me congratulate you on your work and sharing your knowledge. For our regional and international guest speakers, let me reiterate a warm welcome to accompany my thanks. At PSU, our aim is to be at the forefront of higher education in the kingdom. One of our primary goals is to broaden the technical research horizon and to stimulate discussions and social activities that will promote engagement and collaboration, not only for our faculty and students, but also around the community at large. I applaud the Robotics and the Internet of Things Lab for taking the initiative and teaming with IEEE. It may be a great idea to make this conference an annual event as the Kingdom's Vision 2030 approaches. At present, the Kingdom of Saudi Arabia is exploring a dramatic and comprehensive transformation and program reforms en route to a prosperous and sustainable future, not only for the kingdom, but its effect will spread wide or throughout the region and beyond. Last but not the least, I would like to reiterate our special thanks to our distinguished keynote speakers, Professor Muhammad Slayem Alwini from King Abdullah University of Science and Technology, and Professor Fakhri Garai from the University of Waterloo, Canada, who will be presenting valuable talks at this conference. And finally, I would like to acknowledge and thank the organizers of today's conference who devoted their time and talent on organizing and making this unique international conference an overwhelming successful event. Sincere thanks are due to all the general chairs, the program chairs, the session chairs, and the program committee members who were working very hard to review the papers and select the best research work to be presented at this conference. Our appreciation also goes to all the other committees, including publication chairs, IEEE Liaison Committee Chair, Publicity Chair, Advisory Board, and all to the logistics and support teams behind the scenes. It is best to stop here and let the experts in their respective field takes the floor. I wish everyone a successful and a fruitful conference. Thank you all again, and I trust you will enjoy the rest of the program.
Thank you very much, Dr. Ahmed, for the nice speech and presentation. We very much appreciate your support and the support of Prince Sultan University. Now I'll give the token to Professor Azdin Bukarsh. We have been very honored to have excellent scholars as general chairs, Professor Azdin Bukarsh, Professor Muhammad Yunus, Professor Mohsen Gizani. Professor Azdin is going to give a speech on behalf of general chairs. Please, Doctor. Let me just, okay, unmute here.
Can you hear me?
Yes, we can.
Okay. Hi, thanks, Anis, for the introductions. And let me first, on behalf of the organizing committee, extend my warm welcome to all of you attending this first edition of the International Conference on Smart Systems and Emerging Technology, which was supposed to be held at Prince Sultan University in Riyadh. This year, we will not be able to enjoy together the present weather of Riyadh compared to Canada, which is starting to actually today we get the first snow. And also, it would have been more pleasant to visit the Prince Sultan University campus. I have been there, and the campus is extremely nice with all the palm trees around the sofa. It's too bad that with this unpleasant corona that we are having here, we couldn't make it. So we're going to have the conference virtual as you all know. So this conference represents basically a unique event in the region as it targets 6 hot topics which are very important to the region in the Gulf area as well outside, which include information and communication technology, particularly the AI and cybersecurity and the Internet of Things, which are basically one of the pillar area that are very hot those days in our community. And I remember like when I was meeting Anis, we were trying to see exactly what type of conference that we would be having in the Gulf area, and talking about smart systems, which cover a lot of areas. So it fit perfectly nicely with the kingdom, especially what Dr. Yamani was saying. Also, this is the future road of the King Saudi Arabia. The other thing is we hope and believe that this event, as has been announced by Dr. Yemeni, that this will be an established conference in the near future, and why not the leading venue where some of the best research work and trend in the direction of, and in the area of modeling, performance, evaluations of complex smart systems will be discussed and presenting in this conference. And we hope that next year, why not, we will have maybe a chance to have it in PSU. AmStream has been, well, before I go further, I would like to mention that the fact that this conference has been getting a lot of help and support from the University of PSU, we have to really thank Dr. Yemeni for taking his time. He has a lot of things to do those days, especially in this corona. So the fact that he came and he gave his introductions, it means that there is a strong will from the university to push in this area. So Dr. Yemeni, thank you for all the support and help that you have supported. And Anis, I know that he has been very thankful to get you all around. And so, of course, this conference couldn't be held successfully without the help of the organizing committee that include the publicity chair. We did an extremely excellent job into attracting a variety of authors from all over the world with a very good set of paper. I will leave later on Anis to discuss about the paper submission and so far. Also, this year we are very how can I say, very happy to have 2 highly distinguished keynote speakers. One of them is Salim Aliouni, which will be giving his speech on 6G. And tomorrow we will have Professor Fakhri from University of Waterloo, which I had the privilege to work with him on a large project in Canada that I was leading here. And what else? And yeah, so I will leave now Dr. Anis to give his his program co-chair to give an idea about all the statistics that has been going around about getting the number of papers and how the process review has been done and so forth. So Anis?
Yes, thank you very much, Azzeddin. Okay, it has been a pleasure actually to work with you and with all the colleagues to organize this conference. And let me give a brief overview about the call for paper. So first of all, I would like to give deep appreciation to Prince Sultan University. I'm very proud to be at this university for sponsoring, hosting these events, and even much more than this. And without this support, it couldn't be possible to organize this conference. So regarding the call for paper, this is just an overview of the heat map about the distribution of countries that have accessed the websites. So we had 3,865 page accesses since the start of call for papers. Okay, the majority was in Saudi Arabia. We have from United States, from Pakistan, India. So we have had good reachability all around the world. We made a very good dissemination to ensure that to reach as many people as possible. And we had a very rich program from different countries from the region and outside the region here. So for the acceptance stage for the paper, we have received 115 submitted papers, which is a pretty decent number. And we have accepted 40 regular papers. And we had also other papers that we were not able to accept, but we accepted them as a short version that will be presented as a poster. So the acceptance ratio of this conference in this first edition is 35%. So in this conference, we have two types of papers. We have regular papers and poster papers, and they are organized in 6 tracks, which are the hottest topics now in the information and communication technologies, which include artificial intelligence, Internet of Things, unmanned systems, communication and networking, and emerging technologies, and Internet of Things. So the program is going to be split into 3 days. We start every day by a keynote speaker, and then we have the different presentations organized in different tracks. So we organize the tracks such that the papers are related with each other. We have topics related to healthcare in AI. We have other topics related to unmanned systems, Internet of Things, and so on. I would like to give deep thanks to the committee chairs. We were very honored to have with us on the board the general chairs. Also my teammate, Dr. Ahmed Azhar, did a great job in helping with the program and in the review process. Dr. Basat Qureshi did a great job in the publication chair and the relation with the IEEE for the proceedings. Our distinguished general chairs were helping a lot, giving a lot of support and advices for the success of the conference. And we had also an advisory board that is composed of top people from different top universities. And we have also IEEE liaison committee chairs, Dr. Muhammad Al-Mihini from KFUPM and Khalid Mokhtar from Egypt. I thank also Maram Al-Ajlan. She did excellent job in the dissemination. She has been working hard to reach all people here in Saudi Arabia, outside Saudi Arabia. We did very hard work in this regards for the marketing of the conference. So for the tracks of this conference, we have 6 tracks as already mentioned. Track 1, we have artificial intelligence. I would like to particularly thank Dr. Tanzila Saba for all the efforts she did for this track. Also, Internet of Things track, our colleague Othman Baroudi from KFUPM and Dr. Zaid Khan from Prince Sultan University. We have the chairs, Emerging Technologies, Dr. Nidal Nassar from Al Faisal, Dr. Al Hawari Ghoti from Prince Sultan University, and Junaid Qadir from Punjab University in Pakistan. In track 4, big thanks to Dr. Ala Khamis and Muhammad Abdul Qadir Zahana from in the Unmanned Systems track. Track 5, Communication and Networking, Dr. Abdul Hamid Taha and Dr. Fan from China. And finally, the security track, I much appreciate also their work, Dr. Iman Al-Momani from Prince Sultan University of the SEL Lab, Dr. Muhammad Khurram Khan from KSU, and Leandros Magras. So that's all about the committees, and I'm really glad to introduce also our keynote speakers, top scholars in the fields, Professor Muhammad Slim Alwini, a very good friend from KAUST, and he will be working on very hot topics, the 6th generation network of communication. Now we are in the 5G, it starts to be industrially adopted in Saudi Arabia and in some countries around the world. But now the scientific community is just ahead, and they are investigating more about the capabilities of future communication networks, and 6G is going to be the future. So I deeply thank Muhammad Slim for providing us a valuable talk today. And tomorrow we have also a very interesting talk with Dr. Fakhri Karrai from University of Waterloo, very good friend as well. And he will be presenting on big recent advances on operational AI, opportunities and big challenges. Okay, so I think I came to the end of the presentation. I give back the token to Dr. Rcnn to introduce the keynote speech, and we start the conference, inshallah. Dr. Rcnn.
Yeah, can you hear me?
Yes, we can.
Yes?
Yes.
Okay, so before we go further, I would like to make sure that all the people who have been assigned to share the sessions to be a little bit, a few minutes before their session starts. And if they have any issue about how to deal with monitoring the sessions, please contact Anis, because he's the one that is controlling the whole systems. We want to make sure about that. The other thing is, if you have questions, there is on the chat line, so you can just raise your hand toward the end of the speech, either of the keynote speaker or during the presentation of all the authors. So, and then at the end, the people can ask questions in real time. Having said that, we can start with the first keynote speaker. Before he can start giving his speech, I would like to introduce Professor Alwini. He's extremely well known in our community. He is a professor at KAUST. He has a long career, which has been in visiting Minnesota, in the Canada, not in Canada, but in the Gulf area as well. And his current research interests deal with wireless communications. And actually, his work in wireless communication is extremely well known in our community. He received several awards for his work. If I'm not mistaken, in 2019, he received the IEEE ComSoc Technical Achievement Award from the Communication Theory Technical Committee. He also received in 2017 the Organization of Islamic Cooperation's Science and Technology Technical Achievement Award in Engineering Science. In 2016, he received also the recognition prestigious award from the IEEE Communication Society on Wireless Technical Committee. He received the 2016 Abdul Hamid Shoman Award from the Arab Researcher in Engineering Science. And I think he received so many awards that there is no need to list them all, but the list is too long. Sorry about that. And he's, of course, an IEEE fellow, which we all know it's a very prestigious fellow to have. He's also a fellow of the African Academy of Science, the European Academy of Science of Art, the Academy of Europe. He has been the IEEE Distinguished Lecturer for the IEEE Comic Society, as well as the IEEE Vehicular Technology. And he's also, his work has a very high impact. And the testimony of that is his work is highly cited in Scopus, in the Thomson ISI, and so forth. And if I'm not mistaken, he's one of the highest cited in Saudi Arabia as well, if I'm not mistaken as well. So, so we are very happy to have Salim to accept our invitation to give a speech. 6G is a very hot topic today. We are still at the beginning of the 6G, so I'm very interested to see Salim's view on 6G. So I'm going to pass the...
Yes, let me ask to unmute. Okay, right.
Okay.
Yes.
Thank you very much, Azadeen. Thank you, Anis, for this nice introduction. Thank you, Dr. Ahmed, for your also nice introduction for this conference. I pre-taped my presentations to make sure that we don't have to deal with internet congestion, but I'll be available for the Q&A session at the end of the presentation. Thank you. Go ahead, Anis.
Okay, thank you.
Good morning. First of all, I would like to thank the organizer for the
Are you hearing the voice, just to make sure?
invitation and for giving me the opportunity to share some of our thoughts about beyond 5G or 6G mobile network. Actually, some of you may be surprised that we are already talking about 6G while we are still at the very early stage of 5G deployment and in few cities worldwide. But I hope that I will convince you by the end of today's talk that actually we need to start talking about what should 6G be. So let us start by talking about the so-called mobile revolution. Indeed, some argue that mobile is the most rapidly adopted consumer technology in history. This is in one way the result of the merger of the internet, electronics, wireless communication, networking. So, as you know, today we can use our mobile or tablets to make phone and video calls, order things online, check accurately location, and of course our time, access all sort of entertainment like listening to music, watching a movie, and as you know, many more things. So it's kind of mind-boggling that what was regarded as independent services, independent function, I would say even kind of really different tools, different devices just a few years ago have been combined and integrated over the last decade or so in a single mobile smartphone. But we still want more coverage and more connectivity, higher data rates, better access anytime and anywhere, and all of this, of course, in a cheaper, or let us say, in a more affordable fashion. Actually, these increasing demands are something that we have seen over and over again during the past 4 decades. So 1G was in a way the proof of concept stage, and it brought us in the 80s the first mobile phones. During the 90s, 2G made us move from analog communication to better quality, high fidelity digital communication with both voice and let's say texting and emailing exchange capabilities. Then came the 3G era in the 2000s, and with it we moved online and started browsing the internet from our mobile phones. And we are in a way now at the end of the 4G era, enjoying high speed provided by our smartphone. A speed that is expected to go to even higher values and to connect a higher number of IoT device and machine and sensors with the early deployment of 5G this year. Essentially, as we speak, this is happening in many cities worldwide. So as you can notice from the slide in front of you, it takes about 10 years to design, develop, validate a generation of mobile communication system, and it takes another 10 years to deploy it, expand its usage until it becomes mature, in a way obsolete, and it gets eventually retired so that the following generation gets adopted. So you can easily guess that as we start deploying 5G, we, and I mean here like researcher in telecom engineering, we have started already brainstorming and planning for what should 6G be. So we can say that it is essentially a speculative period of time, and there has been more than a dozen perspective, vision, magazine style paper that have been published over the last year or so, giving their vision on how beyond 5G or 6G networks should push the envelope and target higher speeds, more user capacity, and lower latency let's say, for a variety of emerging and future application that we are displaying here in the slide in front of you. So what we can say is that the 6G train, if you will, this 6G train towards superior performance and better quality of service is actually already moving. But at this point, let us look at some general concern as well as, I would say, even specific concerns related to cellular network deployment. First, let us start by making some observations. Obviously, the world is becoming far more urbanized, and mega cities with population greater than 10 to 20 million people are emerging. So there is a greater need for large-scale operation and management for cities to effectively serve its inhabitants. Let us also start looking at the other side of the coin of this so-called mobile revolution and discuss some concern related to power consumption. Indeed, according to a recently published white paper cited in the slide in front of you and reporting first measurement of 5G real-world deployment with all the new features of 5G such as MIMO and or massive MIMO, densification of 5G sites, the use of the millimeter wave band, the connection of millions of IoT devices. So this initial measurement, actually what they showed is, number one, that the power consumption of some bands of 5G equipment is up 3 times of 4G with the same configuration, and two, the number of sites is expected to be 2 to 3 times that of the 4G era in order to achieve 4G equivalent coverage. Of course, this is the case especially in dense urban environment. So this significant increase in the number of base stations and their power consumption will not only accentuate the negative environmental impacts of cellular network fossil fuel consumption, but also bring some kind of financial pressure to like major operators due to the expected increase in electricity cost or electricity bill for these mobile network operators. So we need, of course, to address this critical concern and develop modern green techniques in order to enhance the energy efficiency of emerging and future wireless network to make them more cost effective and also decrease their negative environmental effect. So the objective of this kind of field of green networking is to aim at the minimization of the greenhouse gases emission, and an obvious first step in this direction would be to enforce as much as possible the use of, let's say, renewable energy in the different ICT sectors. And yet, let's say that another natural track is to design low power component, or let us say more energy efficient device and system, but that are able to offer the same level of performance and quality of service from a data rate perspective. This will lead us down the road in this address to talk about this concept of smart radio spaces as one potential interesting solution among others in this direction. This increase in power level leads to another concern related to electromagnetic fields, in short EMF exposure, and with it the concern of the general population about the potential health risks associated with the extra RF emissions from 5G base stations. There is obviously a lot of wrong information floating around, including these online claims linking 5G to the coronavirus, and which unfortunately led this past spring to arson attacks against cellular infrastructure in several countries like the UK, Ireland, Australia. So now, obviously, one has to worry about any possible health effects of radiation, since there is indeed this concern that EMF radiation may lead to all kind of, like skin illnesses, brain cancer, reduced fertility, etc., etc. So the good news is that so far, serious research studies from medical biofield as well as from a radio engineering field perspective could not find any harmful link. As you know, the electromagnetic spectrum is broken into two categories: ionizing and non-ionizing. Ionizing radiation, which includes super high frequencies, such as UV, X-ray, and gamma rays, are of course dangerous since the energy from ionizing radiation can dismantle atoms and even, let's say, break the chemical bonds in DNA, which can damage cells and eventually lead to some kind of cancers. But the microwave and millimeter from a let's say, medical side, is how the EM radiation, especially in the millimeter wave and terahertz range, may affect human cells via other biological mechanism beyond this ionizing, non-ionizing mechanism. And maybe there are some other. So that's kind of the first aspect that one has to look at. And the second aspect, obviously, this is for us network perspective as well as the health and regulation perspective that aim to design, let us say, radiation or EMF aware cellular network for 5G and beyond system. And I will talk a little bit about that down the road. Let me now talk about the third concern by looking now at this map in front of you showing the current worldwide 4G distribution. It's clear that we are suffering from serious gaps in global internet connectivity, which is obviously another important concern. We tend in
Excuse me, some people are claiming that the voice is not hearable. Are you hearing well? Dr. Azuddin, are you hearing?
Yeah. I hear. The slides were off, but now they are back, so it's good.
Yeah, there was just a little bit of internet glitches, but then it went back. If anyone has any problem, please just try to enter again or restart the Zoom meeting. Yes.
indeed to forget that we still have about half of the world population, or about 3 to 4 billion people, without internet connectivity. And it's expected that 5G, at least in its current initial deployment stages, will further accentuate this connectivity divide. Actually, the COVID-19 pandemic showed also that the connectivity divide can be sometimes a matter of life and death for people who are unable to access essential healthcare information and services, and is in a way becoming the modern face of inequality, deepening the economic and social imbalances between the haves and have-nots. Thus, in our view, 6G should be also about connecting the unconnected. And there is a need for more intense research efforts to narrow this connectivity divide in order to offer the often economically and socially isolated unconnected people or underconnected people to experience the transformative benefits that come with connectivity, from access to better health and education services, to smart farming, new opportunities, new jobs, real-time financial service,
and so on and so forth. So now that we went through these three important concerns, it's good to introduce or maybe remind you about the so-called Sustainability Development Goals, in short SDGs. These are objectives that have been adopted by the United Nations a few years ago, and they are essentially about kind of noble targets related to the environment, health, education, equality between people and gender, eliminating poverty, among many other noble objectives and targets. And incidentally, they are supposed to be somehow achieved by 2030, which is the year when we expect the initial deployment of 6G. So with this in mind, let us hope that in contrast to the previous generation of wireless communication network, which were, let's face it, uh, essentially driven by financial and profit perspective, let us hope that the SDGs are going to drive, at least in part, the evolution of 6G, which means that 6G should keep, of course, let's say, pushing the envelope by targeting improved efficiency in terms of bandwidth and power, but also can target lower bad effects on environment and human health. 6G should also be contributing to the development of tomorrow's digitally inclusive world. So as part of our 6G efforts, we should focus also on connecting rural areas, remote regions, and low-income slums. As we rely more and more in our daily lives on wireless communication, an emphasis should be also put on higher and more security and privacy. And of course, again, because we'll be relying more and more on networks, we need to make sure that they are resilient, robust, and essentially reliable. As a wrap up of this part of the talk, and looking at this well-known 5G radar chart, we can say that an equivalent 6G radar, or if you will, spider chart, will probably involve the same classical 5G users scenarios, EMBB, URLLC, and MMTC, but with tighter performance expectation, or let us say stricter requirement. In addition, we may see emerging and future application, like for example in the augmented reality, virtual reality, gaming domains, requiring the combination of the expectations or requirement of more than a single user scenario. Like for instance, we may need to combine EMBB and URLLC type of expectation for AR, VR, or gaming application I just mentioned now. In addition, we believe that 6G should embody the so-called global access to the Internet for all, or in short, the Gaia objective, or in other words, the fact that Internet access must be considered as a basic human right. This can be done by adding an extra user scenario dedicated to a light version of the Internet access, which in the context of a superior 6G standard connection will be providing, let us say, an always-on 4G-like connection, which will be suitable 10 years from now for basic online activities like emailing, web surfing, and audio video streaming for every person. So we talked earlier about this concern regarding power consumption and the desire to go towards more green networks. One concept that emerged recently and that addresses this need is the so-called artificial radio space or smart radio space. In a way, it can be viewed as a natural evolution of communication theory. As you know, in the 40s of the past century, we developed the match filter, or in a way, we kind of focus on optimizing the communication system from the receiver side. And then in the 90s of the past century, we start trying to optimize a transmitter with adaptive modulation, adaptive coded modulations. So the natural kind of evolution of all this is to start actually optimizing the channel itself, the channel that or the medium that connects the transmitter to the receiver. With the artificial radio space paradigm, the wireless propagation environment is turned into an intelligent, reconfigurable space that plays an active role in transferring radio signals from the transmitter to the receiver. So this concept is enabled by the use of intelligent reflecting surfaces, in short IRS, in the environment, and these IRS are constituted of low cost, low power consuming, essentially passive reflecting elements that reflect the electromagnetic waves in desired ways and let's say in a passive manner. I mean without generating new radio signals and basically without incurring any additional power consumption. Essentially, we can say that they're acting like a mirror and directing the signal towards not spots. Let me illustrate that in the following slides. Let us consider this situation where we have a mobile user and a base station with a blockage in between or a poor channel quality. But let's assume that there is a nearby building that happens to have a good line of sight condition with both the mobile and the base station. Therefore, we can take advantage of this configuration to create, let us say, a virtual line of sight connecting the base station to the mobile user using this IRS. Going back to the EMF radiation concern I mentioned earlier, I would like to describe now one of the approaches that we studied to reduce the EMF exposure uh, in order, of course, to minimize the potential health risk. And in our approach, we kind of propose a novel architecture for UAV assisted cellular networks. With this brief overview of tether drones, let me tell you a little bit more about our proposed novel architecture for Tetherdrone assisted cell network, where these drones carry small cells with what we call green, meaning by that receiver only antennas. Indeed, it turns out that actually the harmful exposure is not really coming from a faraway base station. By the time the signal coming from faraway downlink connection reach a mobile user, so basically it's very weak and it doesn't have any harmful effect. Most of the harmful effect may come from actually our own mobile or tablet operating in a uplink kind of situation. So the more far away the mobile unit is from the base station, the higher the power that it's going to utilize and the more EMF exposure or radiation it can basically generate. As such, the idea is to decouple the uplink and downlink. This idea of decoupling uplink and downlink has been used, of course, in different contexts, but here we are using it in the context of EMF radiation reduction. And the idea is that we'll still be receiving our downlink from the faraway base station, but all uplink will be going through these receive only green tether UAV, and they are tether UAV because they will be kind of being placed in optimal location depending on traffic distribution in order to minimize as much as possible the transmit power from the mobile. So the problem is about selecting location of these tether drones in a particular coverage area and then associating the users to particular drones that are deployed in this area and try to come up with an optimization problem where the objective function is to reduce the exposure index given guaranteed quality of service. So we designed an adaptive user Tetherdrone association scheme in order to minimize the EMF exposure, accounting for user inhomogeneous and time varying spatial distribution. In the kind of results I'm showing in the slides, the number of possible location of the tether UAV is 4 times the number of tether UAV themselves. And we used two optimization approach, one which is like the shrink and realign, the other one is the k-means. And we showed that with these two kind of approach, we are able to reduce the EMF exposure with up to 30 and 50% compared to random and worst location of place green antennas, where basically we are not using Tetherdrone at a certain altitude, we are just using a kind of antenna on top of buildings. And obviously, if you don't use any of these green antenna and you just use the kind of standard base stage for both uplink and downlink, the average exposure is in this blue kind of dash curve, and it's much higher. Let us now focus on trying to address the third concern I mentioned earlier, which is about connecting the so-called base of a pyramid. So the base of a pyramid is not the word that I invented myself. It's kind of, was first introduced in this paper by famous economist. It's known as the base or bottom of the pyramid, and it's essentially the bottom of the wealth pyramid or the bottom of the income pyramid. And it's a kind of this largest, poorest socio-economic group. And roughly it's between 3 to 4 billion people that are actually the people that tend to be unconnected or underconnected. So as I mentioned earlier, currently, about half of our population are unconnected or underconnected. They are mainly in rural, remote, low income and low literacy areas, and they are essentially lacking network infrastructure. So, as I told you earlier, one can see that the hope that in the future broadband connectivity will be considered as a basic human or citizen need or right. And if we are able to provide connectivity to these rural areas, we should not only be doing that from a humanitarian goal perspective, but because this is actually an opportunity to generate crucial economic activity in these areas. So, let's say a small step towards connectivity at the base of the world economic pyramid can create a huge market of creative and resilient consumer and producer who are essentially currently excluded from current formal markets. So, like narrowing this connectivity divide will eventually reduce the economic and social imbalance between the have and have not in this digital context. Looking at this global connectivity map published by ITU, we see that the results are essentially not that great, with many countries suffering with serious digital divide. The reasons are many. I mean, besides the basic social reason due to lack of literacy or limitation in the content, essentially there are some strong economic and technical reasons. So the economic reasons are around the fact that the user equipment can be expensive, and they're getting more and more expensive with time. And this area that we are trying to cover might have low population density, difficult terrain, and non-existing infrastructure, basically making them less attractive places to invest and operate a connectivity network. As you know, the mobile network operator operate on a return on investment kind of business model. So it doesn't make much sense to lay 100 if not thousands of kilometers of cable or fiber optics to reach remote, sparsely populated rural areas. Essentially, it makes more sense, obviously, to put this equipment in a highly dense area where you can get maybe hundreds of thousands of dollars of revenue per month, whereas per kilometer square per month, whereas the revenues probably in some of these rural area will not exceed $100 per kilometer square per month. Now, on the top of that, we tend to forget that to have a reliable communication network, we need to also, of course, use a power grid. And in many of these countries, the power grid is either inexistent or in some areas, obviously. And if it's there, it might be unreliable. And by the way, this connected divide does not touch only these remote areas or rural areas or let's say developing countries. It can touch the heart of some of the biggest cities in the most developed countries, essentially the low income neighborhood, the slums, the favela of the world. And the bottom lines is that the main reason behind this connectivity divide is in many instances, number one, as I mentioned earlier, the low expected revenue per area in rural environment in contrast to the much higher revenue in densely populated urban environment. And number two, the typical low expected revenue calculated as average revenue per user, known as ARPU, in low income neighborhood, or let's say like temporary communities like refugee camps. So in both cases, for these two reasons, we have kind of a reduction of the company appetite or willingness to invest in these areas. Going back to these noble SDGs, there is this hope that as part of our 6G effort and with the, let's say, cooperation of partners like internet service providers, network operators, developers, local entrepreneurs, as well as, of course, as researchers in academia and industry, and probably also subsidies of the government, we can explore new ways of bringing fast, reliable internet to those without it. So, as I mentioned earlier, high quality connectivity enables richer communication, sharing knowledge, and strengthening communities as well as their economies by providing kind of health, education, benefits as well as economical opportunities. What we are advocating for is that with global connectivity and the expected technological advances, especially the one based on IoT, we can move out of this narrow smart city concept to the broader concept of, let's say, smart villages, smart towns, smart suburb, in short, smart living. One can enjoy quality healthcare, quality education, and several jobs. Actually can tolerate employees working remotely with all the progress in communication technologies as we have seen over the last few months. So basically, all this can take place in a less crowded, less polluted, not densely populated environment, and in a way, quality living can be enjoyed without having to move to a big city, and this may actually hopefully trigger the first global counter-urbanization of the past, let's say, 6,000 years. So, what did we wait? Let's say, why did we wait so long to achieve this so-called Gaia objective? To answer this question, let's look at the diagram displayed in front of you, where you can see that traditional geostationary satellite communication system, which are of course great for TV broadcasting, but offer limited bandwidth and suffer from a high latency as far as internet browsing is concerned. So they cannot deliver fiber quality for our purpose. This same diagram illustrates that full deployment of fiber cables or microwave wireless link is not economically feasible for remote areas which are typically characterized by a low density of population. So our goal as part of our 6G effort is to go after what I call the global connectivity holy grail on the top left of the diagram displayed in front of you. So I mean by that, we are going for the best of both worlds and target a terrestrial fiber quality, but with a global satellite coverage, hopefully fulfilling the prophetic prediction made 100 years ago by Nikola Tesla, and that you can read in this kind of slide displayed in front of you. But the question is, I mean, how can we do that? The answer is integrated space, air, ground networks. Indeed, global coverage without relying on the deployment of costly infrastructure on the ground will depend on the deployment of three-dimensional integrated network that include terrestrial, airborne, and satellite communication. As such, flying network platforms such as UAVs, flying cars, tethered aerostat or blimp, and high altitude platform could become ever present in the future. Now, in this context, we are studying novel wireless communication schemes that integrate these three layers and that are aiming to support land, maritime, and even flying user and devices. More specifically, what we are after is actually self-organized network that one rely on terrestrial base station, drones, balloons, high altitude platform, and non-geostationary satellite. And two, these different layers adapt their structure and their resource allocation based on the ground population density and the quality of service requirement by the, let's say, application utilized by these population of users. So obviously there are two kind of interesting research direction here. There are effort on the backhaul aspect and there are effort on the access. I focused in my presentation on building tomorrow's technology to connect the next 4 to 4 billion unconnected people. But beyond that, actually bringing global connectivity can also activate the use of various Internet of Things technologies, including Internet of Underwater Things, Internet of Underground Things, and Internet of Space Things. And in this context, research now suggests that using these Internet of Things technologies in a fully connected world will help, for example, with one, smart farming application, which can improve the cost efficiency and safety of food production through digitalization of the agriculture and agriculture value chain in general. And two, in monitoring global climate change, which, as you know, is a big challenge that requires great attention from the scientific community because global climate change is significantly affecting the life on planet Earth.
In conclusion, I would like to thank you for your attention and conclude that as telecom engineers, we have no choice but to keep pushing the envelope, fulfilling this other interesting prediction made 100 years ago by Nikola Tesla. But clearly, I hope that I convinced you that we should do that. And actually, I'm confident that we can do it while being more inclusive and in a green, sustainable, and also health-aware fashion. Thank you again.
Thank you very much, Sim. Yes,
So now we're going to leave the floor to people who have questions. So what they should do, they should raise their hand. There is an icon that says raise a hand. Anis will see it, and then he will give him the mute and unmute.
Yes, you can raise your hand and I can give you access to talk. I have some questions to ask.
Okay.
Yeah. First of all, I would like to thank Slim for the excellent presentation. It was very instructive talk. So I have a couple of questions. Now, can we tell that the 6G is the new standard for the last mile carrier? This is what I mainly understand from the presentation. It's going to be like the last mile carrier to connect people that are in rural areas that are not connected. Can we say this? Okay.
Unmute Salim.
Yes,
Okay, thank you. Yes, I was not able to talk. Thank you, Anis, for the question. That's actually a nice way to summarize it. Really, I like it because I think the previous generation of systems kind of tried to essentially solve this last mile problem only in urbanized environment. And there is this blind spot or the blind side of 4G and 5G, which are great for, again, urban, highly dense environment, but they are not solving the problem in, sparsely populated areas, rural communities, hard to reach areas or provinces, as well as actually low income neighborhood, as I mentioned in my talk. So solving the last mile problem in an economically viable fashion is definitely one, in my view, one of the objectives of 6G. 6G is not only about that. What I focus today about is, some of the things that we tend to kind of neglect or forget. In particular, this connectivity divide, but also I think this energy efficiency, it was a big thing maybe 10 years ago. Then somehow we tend to forget about it. But I think now when we see the initial deployment experimental result from 5G, I think it's a big thing, and we need to go back and look at green networking and ways to do things in a more sustainable fashion. And I think the third aspect to try to emphasize that we tend to forget as engineers is this EMF exposure problem. Although I think most of us, if not all, are convinced that I think we are doing things in a safe way. But at least we need to communicate that better. It doesn't make sense that every time we roll a new generation of systems, we have to go through this kind of media backlash where, as soon as you talk about 5G, the next kind of question is about how healthy it is it killing birds, and all kind of issues related to that. So we really need to be ready. We need to do our homework to be able to answer in a scientific fashion that not only it is safe, but it is safe because this, and we need to do more research in checking if there is an issue, and anyway to try to do our best, like I try to highlight in some of the work we are doing nowadays in my group, what I call EMF aware network planning, which means you try to maintain the quality of service, but you try to minimize your emission. There is no point to do kind of pollution of electromagnetic waves, and focus on delivering while being kind of let's say EMF aware. So, but going back to the question, yes, I think solving the last mile problem, it's an important issue. Let me, because I'm, and I know I'm taking too much time to answer this question, but I think it's a very nice way to formulate it. I would like to link that to another important topic that unfortunately I didn't have time to talk about in my talk. Is this last mile problem actually is a general problem, in my view, not only from a communication perspective, but also from a transportation perspective. Communication engineers, we are moving bits from point to point. Transportation systems, that are moving people and goods from point to point. The last mile problem is also a problem in transportation system. And the way transportation engineers are trying to solve the problem in the next 10 years is basically the so-called flying autonomous vehicles. Probably you have seen these kind of futuristic YouTube kind of movies or documentaries about flying taxis, flying autonomous cars. That's one way to decentralize, to basically make it easy to go and solve the last mile problem. And the nice thing is that these two problems are very well connected, because if you want to have these flying cars, and you need them to be connected, because you need to be able to control and command them, you need to deliver internet for people in these flying taxis, so basically they can get connected while or being in their trip. You need this aerial network. You need these hubs and these satellites to connect these flying taxis. So I think there is this interesting connection between the last mile problem in communication and the last mile problem in transportation. And at the end of the day, both of them are going towards the same objective. The objective to basically, just to make it in very simple words, you want to basically bring economic prosperity to these remote regions, to these remote provinces. There is nothing better than putting a train line, putting a highway, and like a physical highway for cars and goods, but also a kind of a telecom highway so that we connect people there. So solving the last mile problem will allow to basically, hopefully, bring more economic benefit to all of these remote regions. And in a way, as I mentioned in my talk, kind of try to minimize this urbanization kind of the trend that we are seeing. Because if people are able to work, make good money from wherever they are, there's no point so they move to cities or even emigrate. People will be able to be competitive and get opportunities wherever they are. So like anything, you need the initial investment. And once that initial investment is made, you can bring a lot of prosperity, and you can make these remote regions or rural area providing more economic opportunities.
Yeah, thank you very much, Liam, for the response. And actually, your response brings me to other questions that I already also mentioned. So the first one is about the economical and business perspective. Now, from the business side, what kind of investment is required from telecom companies? Now, I remember that after finishing the research about 5G, there was a lot of dilemma in the telecommunication company to adopt it and deploy it from industrial perspective. And I think until recently it was deployed. I remember that there are some political discussions about whether to go for 5G or not 5G, like maybe 2 or 3 years ago, but now it's running. Do you think that the telecommunication company are going to invest for reaching this last mile? It will be effective for them from financial perspective?
So this is a major challenge that kind of stop us from or stop the companies to go to these remote areas, because again, it doesn't make much sense with traditional approach. If you go with traditional approach, I'm going to put a base station on the ground and the base station is going to have this particular radius. That's not going to work. You need to go in altitude. You need to go to these macro cells. And you do that either by towers, mast, but they can tend to be expensive, which means you need to go into space. And that's what I'm trying to advocate for. You need to use UAV, tethered UAV, balloons, hubs. This is the way you can get your 100-kilometer footprint with a single base station. And then you can become economically viable, okay? But of course, there are other issues. There is also literacy, computer literacy. There are a lot of people in these remote areas that don't know how to use a computer. So it's an effort and how to make this, of course, cost effective. You want to have like relatively cheap business, cheap kind of, these kind of cellular network or data plans, let's say, that are kind of not confusing. You need to come up with low-cost solution. You need some time to get some government subsidies. As I told you, it's like when you want to make a remote region prosperous. You put a highway, you put a train lane, and the government has to pay the initial investment. But this is like you will have your return on investment because you'll make that region prosperous. You'll bring economic activity to that region. You'll bring job opportunity for that region. Agriculture will be able to sell their products and have access to the market in real time and sell their product at the right price. So I think it's a combination of good technology, a social aspect like literacy, government subsidies, and I would say, and that's maybe my last kind of comment in response to this question, how to say, I'm not sure if you're aware, but some of the best research in this topic of, let's say, global connectivity or connectivity divide is not done in academia. It's done in the labs of the GAFA companies, the Google, Amazon, Facebook, Microsoft. They have very good research there because they realize that actually, if they want to expand, they are pretty much saturating in the urban environment. If they want to go and get more subscribers, then they will get that in these kind of unconnected areas. And that's why there is all these interesting and very ambitious kind of mega constellation of Amazon, Kuiper, they're trying to send not 100,000, tens of thousands of satellites in the air, Kuiper, if you can Google that. Facebook, they have the Telegraph project. Google, they have the Loon Balloon project. So all of these companies know that the next kind of subscribers, the next people that will be able to enroll in a low-cost fashion is going to be the base of the pyramid that I was talking about. Yeah. So I think there is a business model from different perspective. And to me, 6G or 2030, by then, we should be able to solve our problem.
Excellent. And it seems that there is a trend to use aerial unmanned systems for this kind of last mile connection. How realistic is this? Because now the current drones technologies, are very limited in terms of energy. They can fly maybe 30 minutes, 1 hour, 1 hour and a half at most. So excellent. How can you make it sustainable?
I mean, we can stay for hours here, Anis. I mean, this is the topics I am dealing with on a daily basis. Yeah. So obviously, the aerial solution, we know that's the way to go. But how to make it practical? So one track that we are pursuing, and you can check, of course, I could have talked about that, but actually I have another keynote speech focusing on this, is what I call tethered aerial solution, tethered, with the cable. Okay. So these are hybrid solution in between ground and air. So you have a Tetherdrone, a drone connected to the ground with a tether of 150 to 200 meters. So you have the aerial aspect, but the tether is going to give you the power supply so that you can fly for days and give you the fiber optic backhaul link. And this is not science fiction. Many companies are selling now this tether. Initially, they have been used more for border control, for camera, things like that. But at the end of the day, it's a payload. You can choose to put a MIMO system there, and then you have your aerial base station. We have few papers on that. I invite you to read them. One of them is in VT magazine, the other in Transaction Communication. They have been published in the last couple of months. Then you can go even higher. We talked about this tether balloon or tether airships. A company like Alteros in the US, RTO Wireless in the US are basically advocating for this tether solution. Now, if you want to go even higher and get a bigger footprint, again, while solving the energy efficiency problem, there are these hubs, and there are two families of hubs. Some of them are using solar energy, like satellites. They tend to have a limited payload. But recently, there has been a breakthrough, and there are now hub company that is advocating for hydrogen fuel cells, which means that you can have a hub flying at basic 20 kilometer altitude in the stratosphere that can carry a payload of 140 kilograms. You can put a massive MIMO system there in the air. Right. And again, the key point here is these hubs, these balloons, these UAVs do not require special phones. You can use your standard iPhone, your standard kind of Galaxy phone to connect to this air base station. For the user, it's transparent. He or she doesn't know that he's connected to this UAV or to this balloon, right? This is different than the mentality or the idea that, at least when I was a graduate student in the early 2000s, basically this kind of satellite kind of solution, they came, but they were not successful because they were relying on these specialized phones. And that's why they were not successful. Now you use a standard phone to connect to an area network, either through a terrestrial relay or through one of these hubs or these balloons or UAVs.
Yes, thank you very much. Thank you very much, Slim. I appreciate it. Dr. Asdeen, yes.
Yeah, I have a question where some question has been asked by Anis and others were basically in your answer. So when you were talking about some of the application, you were talking about augmented reality, game and so far, which 5G was also talking about it as well. So what 6G will bring to augmented reality on top of what 5G is already seeking?
As you know, Azadeen, I mean, at least from my perspective, these 5G, 6G, 7G are marketing words. The reality is it's a continuous process. And things, you don't push a button and you say, I'm going to move from 4G to 5G. Usually, if you have been following these standards and 3GPP recommendation, typically we are talking about a natural evolution. So to my best knowledge, we still didn't solve the AR, VR problem fully. So we are, it was a wish list at that time. maybe we had done some progress, but are we really talking about ultra reliable, low latency communication at 1 milliseconds everywhere? I don't think this has been accomplished yet. So we are going towards that goal. And some other people think that always the odd Gs are just wish list, and the even Gs, basically deliver. So basically, like for example, 2G was a breakthrough compared to 1G. 3G was just kind of saying that we are going to do things, but actually not much was done. 4G actually solved many of the 3G wish list. 5G is going to be again this bridge that will lead us in 6G to solve the kind of issues kind of wished or hope to get during the 4G era.
Okay, that leads me to what you were saying before when you were talking about 6G. You were talking the last mile, and Anis also was saying the last miles, and that reminded me that a few months ago I was attending early last year. I was attending a conference that Halim was from Carlton. There was a keynote there, and then he was talking about, I think 6G, it will be the last one.
Maybe.
Right?
I mean, yeah, go ahead. Sorry, Azdi, go ahead.
So if we're going to keep going about what you say, like 4G, 5G, 6G, 7G, so until when we're going to keep going? This is like I'm playing the devil advocate here.
Yeah, honestly, I have seen Halim talk, and Halim has been talking about HAPS. He has a very nice talk on HAPS and things like that. So we are completely aligned. So, I cannot predict. I think, again, to me, this is used as a marketing tool to kind of as a flash. Okay, we are here. And I don't see why we'll stop it, because it's a nice way of putting objective. And I think people got used to that. So like, if you notice, we start talking about 5G in our academic circles, maybe sometime around 2004, 2005. But we are talking about the 6G, 2015, 2014. We are talking about 6G now, 2019, 2020. So people already are programmed now, okay, and there are a lot of initiatives, a lot of funding in Finland, in many countries, there are like flagship projects about 6G. Because I think people realized that actually, if you want to influence the vision, the standard, you need to start talking early on. You don't want to basically end up with this ITU document as a fait accompli just after fact. And people are pushing their agenda, companies, people like myself, yourself, everyone in this room, probably, we are trying to kind of shape or say 6G should be about that. That's why when we wrote our paper, we said, what should 6G be? Because that's our vision of 6G. In my perspective, I want you to focus on the sustainability aspect that have been kind of somehow, in my view, a little bit kind of neglected or not emphasized in the previous generation system. But as you know, I don't think there is a ceiling to progress. Maybe 7G, 8G will be about space communication, how to create a cellular network in the moon, how to make sure that someone in the moon can communicate in real time with someone on Earth. We cannot predict what the future is going to be, and then you want to attach to it the name 7G, 8G. That's a different story. But in my view, I mean, there is nothing that we can say we have solved the communication problem, because there'll be always new problem. Maybe teleportation. People are talking about sensing. Even as part of 6G, you have seen in some of the recent workshop in ICC Globcom, people are talking about the Internet of Touch or Internet of Sense, where basically you are able to transfer maybe smell or kind of things that or touch things that we have not been basically used as a way to communicate or to transfer. So like anything in research.
Now we are talking about the SIN, the Space Information Networks.
Yeah, that's what I'm saying. Like space. What I talked about here is space more to connect the people on Earth. But maybe 20 years down the road, or even 10 years down the road, when mission to the space can become kind of pretty much kind of a reality, then we need also to connect people beyond the Earth, right? We need to connect people in the moon or during their trip between the moon and the Earth. So as I said, we cannot predict how the future is going to evolve.
Okay, so when you talk about the terrestrial networks and so forth, I didn't hear you talking. What is because a lot of people are talking now about the cloud, edge computing, edge networking, and we keep talking. So how this is gonna affect or get involved with this 6G? Is there anything that is related to that?
I think like the edge computing, all the networking aspect, I think virtualization, edge computing, definitely I think are big part. I'm not, as you know, I'm not an expert in that, but I have seen many of the networking people getting into this. One of the main motivation is delay. Obviously, you know, when you go in altitude, I mean, and that's why you don't want to rely on geostation satellite. You don't want to experience, like, you know, these long delays. So the lower you go, the more edge computing, the more close you come to the user in terms of decision, in terms of transfer information, the lower the delay, and the more practical, the more enjoyable is the communication, the more kind of range of application you can start using for this. So definitely, again, I'm not an expert. This is not my area of expertise. But actually, in collaboration with Bassem, I don't know if you know him, Professor Bassem Shihada in KAUST, we have been doing with a joint postdoc a little bit on this kind of edge or computing with satellite, or at least slicing aspect, where basically you can send different kind of traffic on different layers. Like when you have very low latency requirement, you can go to terrestrial network. When basically you have a little bit higher latency kind of kind of relaxation, or you can go through an aerial solution, which tends to be always coming with a higher latency. So definitely there is interest in using edge computing and in the satellite or in the UAVs or on these bombs.
Okay, well, I'll leave the chance to other people to ask questions for who are attending, if there is any. Please raise your hand and this will pass the message.
Any other questions? I think I have seen a question here, but it was written. Let me go back. It says, would it be possible to share the link of the video? Okay, no,
that was when the network was down.
Yeah, I thought that this about the, yeah, okay.
Sure, no problem. I mean, by the way, I'm not sure if I shared with you the PDF slides. I can share them with you, Amir, and nothing confidential here. We are here to distribute information, so feel free to make it available to all the speakers. Sorry,
Okay.
to all the attendees.
Yes. Thank you very much, Slim. I really enjoy your talk and the discussions also.
If there is no more questions.
Yes.
So if there is no questions, I think we will should thank Salim for the exciting talk. Very informative, and indeed, this is a topic that probably is going to be going on for the next 5-10 years.
Yeah.
Like what you say, every 10 years there is new generations. So thank you very much. And if there is any people who want to talk to him on offline or something, they can always get in touch with him. Thank you very much, Slim.
Thank you, Azadeen.
Thank you.
Anis, and I wish a successful conference for everyone.
Thanks a lot. Very much appreciated. Thank you. Bye.
Bye.
Okay, so we're going to start in 5 minutes, the first session. So just to take a 5 minutes break, and we start the first session of the conference, which is about artificial intelligence. Okay. So just the speakers for the first session, please be ready to present. Please contact me in the chat. So, okay, Al-Batul Hamidi is here. Okay, that's fine. So I would appreciate that all the speakers will just post a message on the chat to make sure that they are here. Bismillah ar-Rahman ar-Rahim. Okay, we can start the session number 1, which will be about artificial intelligence and computer vision. We have 3 talks. So the first talk is about automatic gun detection from images using faster Rcnn. So I would like to invite Batul, I think she's here, to make the presentation. Let me give access. Okay, you have a token now. You can share your presentation.
I can't share the screen.
Yeah, let me give you the access for this. You can try now.
Yes. Greetings. I am here on behalf of my team to present our project, which is automatic gun detection from images using faster Rcnn. My colleagues are Rana Al-Agil, Ridis Haibani, Ragad Al-Nasser, Rahab Al-Ataybi, and our supervisor, Hafid Ibn Hadri. We came from the Department of Computer Sciences in King Saud University. Once again, a lone gunman kills unarmed civilians is a headline we've grown used to reading. Shooting accidents are happening too often these days that we got used to hearing about them in daily news flashes. What if we had an automatic gun detection system that will save so many innocent lives? This is the question that triggered the idea of our project. The problem consists of taking an image as an input, then passing it to a detection system to obtain an annotated image with a bounding box surrounding each gun present in the image along with its class score. As you can see, this is the input, this is the system, and this is the final output of our system. There are many computer vision problems, but in our research, we are focusing on the object detection problem. In this specific problem, the system is not only able to identify different objects, but also detect their specific locations and surround each instance of the object with a bounding box along with its class score, as you can see in the output image. Faster Rcnn is a state-of-the-art network. It has a very complex architecture that consists of 3 integrated networks: a pre-trained feature extractor, a regional proposal network, and a fully connected network. The detection is done on many stages. Here I will take you through the process. First of all, you can see over here, I'm talking about the feature extractor part. The image is passed to the feature extractor, which is a pre-trained network that creates a feature map by encoding the image information. As you can see, the output of this stage is a deeper but smaller representation of the image. The following step is generating k number of anchors. For each anchor, there are 2 outputs. One is the objectiveness score, and the second is the value of adjustment needed for the anchor to better fit the ground truth. This step leaves us with a large number of region proposals. We use non-maximum suppression function to choose the best proposal to pass to the next stage. The following layer that the image is passed to is the Roi Pulling Layer. This layer takes each region proposal and its corresponding part in the feature map and resizes it to fit the fully connected network. Finally, for the classification part, the proposals are classified by measuring their overlap with the ground truth. If it exceeds 0.5, it gets assigned to its corresponding class. For the related work, there was Faster Rcnn by Verma and the others, where they tested 3 different classifiers in the Faster Rcnn architecture. They experimented with the classifiers where we experimented with the feature extractors. So here's the difference. There was also You Only Look Once by Rodrigo and the others, where they implemented You Only Look Once model. For our contribution, we trained and tested 4 feature extractors for the Faster Rcnn architecture and compared the results of gun detection with YOLO V2. For the dataset, we used 3,831 images obtained from the Internet Movie Firearm database, which is publicly available. We split the data to 2,746 for training, 600 for testing, and the remaining for validation. Now, for the evaluation of our models, we've done several experiments in order to reach the best results. Ordered from lowest to highest, you can see that MobileNet V2 achieved the lowest mean average precision rate of 70% mean average precision, whereas the model with the highest mean average precision was Inception Resident V2 with 81% mean average precision rate. And ordered from slowest to fastest, the slowest model was Inception Resident V2, whereas the fastest model was YOLO V2 with 0.02 milliseconds per image. Comparing our results with previous work done in the field, we can see that Verma and the others experimented with the classifier part of the feature extractor and obtained the following results, where we experimented with the feature extractor part and obtained the following results also. For the YOLO model, our implementation for the model achieved 74% mean average precision rate, which is higher than the result obtained by Rodrigo and the others, as you can see. These are examples of the images that the models were tested on. This is an image of a partially visible gun that got correctly detected by Resnet 50, and Inception Resident V2 and YOLO V2. And this is another example of a gun on a reflective surface that got correctly detected by other models. Finally, to conclude, the project uses faster Rcnn to detect guns from images. We trained and tested 4 feature extractors using Internet Movie Firearm Database dataset and compared our results with previous work. We concluded that the model with the highest mean average precision rate is faster Rcnn with Inception Resident V2, and for the future work, we plan to enable detection for other weapons and address the problem of guns classes where the system identifies guns classes, for example, rifle, revolver, etc. Thank you for listening.
Okay, thank you very much. Are there any questions? Are there any questions from the audience? You can either write or you can raise the hand to have the mic. Okay, so I have a few questions. You have used faster Rcnn.
Yes.
Did you compare the detection time? I mean the execution time for the detector.
Yes.
Because YOLO is known to be faster than faster Rcnn. I don't know if you have made any comparison in terms of execution times.
Our main contribution is testing different feature extractors, but for the sake of comparison with the state-of-the-art models, we compared with the YOLO V2. But for the main purpose was to test feature extractors of faster Rcnn.
Yeah. What was the batch size that you have used for the training? Did you use the same batch size for
all the models? Yes.
For all the models, what is the batch size that you have used and the optimizer?
I can't recall, but my colleagues are here, so they will, if they can answer, have me answer.
Okay, they can answer, but they need to raise their hand to.
Yes.
Okay, thank you very much, Batul, for your work. Okay. Okay, now we are ready to go for the second presentation, and you have Alam Noor. Okay, let me give the mic to Alam. So the second talk will be about DriftNet, aggressive driving behavior detection using 3D convolutional neural network. It's a research work that has been done in our research lab with Alam Noor, Bilal Benjdira, Dr. Adla Ammar, and myself. So Alam Noor has completed master's degree in the field of information and communication engineering from Harbin Institute of Technology. He is currently doing a research internship in the Robotics and Internet of Things lab at Prince Sultan University under my supervision. And his current research focus is on anomaly detection in videos using deep learning, machine learning, data processing techniques for real-time applications. So Alam, you can start your presentation, please.
Thank you, Professor. Hi, this is Alam Noor. Today I'm presenting DriftNet, which detect aggressive driving behavior using 3D CNN. This work is done under the Robotic and Internet of Things Lab, Department of Computer Science and Information Security, PSU, with the supervision of Professor Anis Koba. Here we can see in the video that our lab is working on the different projects, and our contribution in this work is that our contribution and motivation in this work is that aggressive driving behavior is very dangerous to human life. We need a method to detect this behavior from surveillance cameras on the road. No one targeted this issue using deep learning. This is the gap. We need to design a practical system to detect this behavior from surveillance videos using a deep learning approach with the help of 3D CNN, because video needs 3D models for processing. We can see this is the destruction of the properties, also the loss of human life. Problem statement is aggressive driving behavior can be detected when the vehicle begin to drift unexpectedly. You can see from the pictures. To solve this problem, we need to process a full sequence of frames to extract the special and temporal feature related to it. Summary of the work is related to: first, we propose a new anomaly detection framework applied to the detection of aggressive driving behavior. Our contribution consists in the development of a 3D neural network, development of a 3D neural network architecture based on the state-of-the-art DenseNet 2D. We evaluate 3D architecture using transfer learning for the drifting datasets. We borrow the same training settings from 3D DenseNet, C3D, and convolutional LSTM. We take the kinetics pre-trained weights and fine-tune it to the new dataset, because kinetics is used for the video and 3D models. Background of this project related is we construct a dataset for drifting in normal and drifting in normal. This contains small videos classified into classes drifting. Our problem is a video classification problem. We built a deep learning model, DriftNet, based on the DenseNet 3D CNN model, which introduced in 2019. The DenseNet 3D CNN is written on the we choose for this in background kinetic weights. We compare this model with the two or other models, C3D model, which introduced in 2015, and convolutional LSTM, which introduced in 2017. We found that DriftNet outperform other methods as compared to other methods in this task. These are the three architectures which has been used in this research. C3D has 4 dominant videos characteristic: generic, compact, effective, and easy to use. C3D has been built with 8 convolution layers, 5 polling layers, 2 fully connected layers, and a softmax output layers, which has been shown in this figure. One can train a C3D with 3x3x3 as deep as possible using a large data set with the limit of memory and accessibility for computations. While in convolutional STM, and you can see in the figure, the convolution layers are trained to extract dynamic characteristic from video frames and then combined with the convolutional STM layers. In the backend of the convolutional STM, the pre-trained AlexNet model used for frame level extraction on the ImageNet database is a CNN application. The input of Rcnn 3D takes video frames and created 64 features maps with through the convolution layers. The following first dense blocks then handle these functions maps. The dense blocks consist of many layers that have densely connected. Pre-activated bottlenecks architecture is used in each dense layers. The transaction layer is positioned between two dense blocks, and the transaction layer's objective is to sample down maps. The number of our output and input functions map is balanced between neighboring blocks. These are various new patterns in each dense layer, where those new patterns are called growth rate. The average global pooling strategy was obtained at the end of ResNet 3D to link convolutional layers to a fully connected layers. And finally, we compare the contribution was we introduced the contribution, that summary of contribution. So and finally we reach that DriftNet dataset with 3D CNN, and also used DenseNet is a fine-tuning transfer learning, can comparatively very high accuracy as compared to other models. These are the parameters which have been used for the data for the training of the models. These are the images for the training has been used 7,840 and 1,960 for testing set, and the 80% data set has been used for training and 20 for the testing. The DriftNet frames consist of 3,920 frames, and also same from the non-drifting frames. The input shape was 112 cross 112 for the all of three model for the comparison. Frame samples was used as a 32 is a bit size. Augmentation used here we used augmentation also, and two optimizer has been adopted, and also learning rate or momentum used like this. We can see this. These are the say 3D his 73.12% accuracy, and conventional STM is 86.25% accuracy, and DenseNet 3D has 96.87% accuracy, while testing accuracy is 67, 65, and 77 respectively. These are the graphic results of the all three models, and these are the training loss and validation loss, and these are the training accuracy and validation accuracy. Our achievement, the proposed models definitely has shown efficiency in detecting aggressive driving behavior from videos, and also efficient for is a time processing and used to detect driving behavior. We use this for real-time videos on the road, like we test with the other videos. And also the limitation was the one is like boundary box. We did not we are working on it. It can only detect that there is a drifting car in the frame, but not able to localize it like this. It can work only on low video resolution due to limitation related to the processing power as a GPU. Thanks for watching.
Okay, thank you very much, Alam. Now we open room for questions. Are there any questions? Okay, thank you. I think there is no question from the audience.
Thank you, Professor.
Okay. Now the next talk is about automatic smart UAV search of lost floating target in ocean environment based on high dense clustering. Is one of the authors here, Mahras Bulares Ahmed Barnawi. Any of the authors is here? Okay, I think that the authors are not here. Okay, so with this, we come to the end of the first session. And we will start the second session after 10 minutes from now. Dr. Saada, you are here. Dr. Saada Habiban from CAXT is going to lead the next session.
Yes, I'm here, so I will start in 10 minutes.
Yes, okay. At 10:30, we can start the next session. Okay, since we have the presentations, I'm going to run it as a video because the authors are not here. So I'm going to run the video if it is available.